Welcome to the MS podcast series. This is a research update episode. I'm Nicola Graham. I'm really delighted to have your company today. We're looking at a really hot topic. It's EBV, or Epstein Barr Virus. It's currently all over the media as a possible cause of MS. But given over 90% of the general population has EBV, they don't all go on to develop MS. We want to know what's going on. What does this all mean? What does it mean for you? What do you need to know so that you can make sure you're getting the best treatment possible? So please stay tuned. We'll answer your questions and concerns with real science. And I'm going to be picking the brains of Brett Drummond from MS Translate. Welcome, Brett.
Thanks, Nicola. Thanks for having me.
Pleasure. So let's start, Brett, with what is EBV, or Epstein Barr Virus? Is it what we commonly know as glandular fever or mono?
Yes, it's a really good place to start, because I think this is one of the things when it comes up in the news that's quite confusing for a lot of people living with multiple sclerosis, but people in the general population as well. So Epstein Barr Virus, or EBV, is the virus that does cause glandular fever or infectious mononucleosis, or mono as it's called in different parts of the world. But I think the important thing to realize about this is that most people who are infected with EBV don't go on to actually develop glandular fever. So most of us have been infected with this virus at some point in our lives and never have any symptoms. So we're not aware that we've come into contact with this virus. And as you so rightly pointed out in the introduction, more than 90% of the general population has been infected with EBV at some point in our lives, but certainly nowhere near that many people that have had glandular fever.
Okay, thanks, Brett. So EBV's long been associated with MS. What's all the noise in the media about right now? Has something significant happened?
Yeah, so it's a really good question. So I started in multiple sclerosis research more than 15 years ago, actually, when I started in the research lab, and EBV was something that was talked about then and had already been being talked about for a long time at that point. However, our understanding was quite difficult because, as we've already said, we know that more than 90% of the general population have been infected with EBV, and at the time it was thought that around sort of 94 to 95% of people living with MS had been infected. So there was this idea that seemed to suggest, well, it seems to be more common in people living with MS than the general population. So is it somehow involved in the disease? But when we're talking about 90% of the general population, it's hard to see that as, anything more than a coincidence necessarily, that it's slightly higher in people with MS. But yes, things have changed over the past 1 to 2 years, because there's been a couple of critical studies that have shown some new insights into how EBV might be involved in multiple sclerosis. So last year there was a German study that was published, and what was interesting about this study, had more than 1,000 people in the study, so it's quite a large cohort of people. But what they found using some new techniques that are now available is that they saw that 100% of people living with multiple sclerosis had been infected with EBV. So they found that everyone who had MS had also been infected with EBV, compared to that roughly 90% of the general population. So this was the first time that really suggested that perhaps to develop multiple sclerosis, there had to be an infection with EBV, that it was a necessary part of the disease developing. Now, this has been followed up more recently by a new study that's come out of the US through Harvard, using a cohort of military personnel actually in the US, they have some really exciting research that can come out of those people because they have a lot of medical information of them across their lifetime. But the important thing from this, again, was that in this study, which was again around 1,000 people, they found that, again, 100% of people living with multiple sclerosis had been infected with Epstein Barr virus. And so what this was sort of showing was that it seemed to be that an infection with EBV was necessary for MS to develop. And we're going to talk a little bit later about whether or not that means it's the cause. But this was new information that really showed that everyone with MS in these two large studies had been infected with EBV at some point.
So that would have caused a bit of a stir, I imagine, Brett. So I'm going to go straight to the nub. Is it the cause of MS? Is EBV the cause?
Yeah, good question. Short answer is no. But I think we need to be a bit more careful about just saying no. There is more to it than that. So I think to get to the quick answer of it, and then we'll give a little bit more detail on that. Our current thinking, and it's still hypothetical at this stage. We've got some good evidence based on these studies, but there is still more work that needs to be done. But what these studies are suggesting is that an infection with Epstein Barr virus is necessary for multiple sclerosis to develop, but it's not sufficient. We know that there are a lot of people who get infected with EBV who never go on to develop MS. So it's not the EBV infection alone. But what these studies seem to suggest is that you can't develop MS if you've never been infected with EBV.
Wow, interesting.
And what was interesting, just to go into that US study in a little bit more detail, what it added on was that because they had these time points throughout the person's life, they did have some people in that study who were EBV negative at the start. So in their first blood tests that they had from those people, they hadn't been infected with EBV. And what they could see using a marker of nerve damage, and we won't go into the details of that, but there are some things that they can look at in the blood to see whether or not there is any damage occurring to the nerves. When the individual was EBV negative, so they hadn't yet been infected with the virus, there was no nerve damage that was occurring. And when they looked at follow-up blood samples, so blood samples from later in their life, they could see that at the time point when they then had been infected with Epstein-Barr virus, it was only after that then they could start to see this nerve damage occurring. And so this gives us a really good insight to suggest that, yes, this infection with Epstein-Barr virus, not alone, but the infection with Epstein-Barr virus is necessary. Now, what else is going on? What actually is the cause? Well, it's likely then if the virus infection is necessary, that it's somehow interacting with other environmental and genetic factors that we know are important in multiple sclerosis. We know that there are certain genetic susceptibility factors, so different variations of genes that make a person more likely to develop MS. Now, how exactly those genetic factors interact with the Epstein-Barr virus, the EBV, we don't know that yet. There are some suggestions around how it may be involved in the cause, some other recent research that's come out on that, but there's still a lot to know in that. But it's likely that it's the infection with the virus is a bit of a trigger interacting with other environmental factors, other genetic factors in some sort of a perfect storm, all occurring at a bit of the right time, or I guess the wrong time really, for MS to develop.
So there's a number of factors required, but EBV is a verified component of that.
Is one of them. And yeah, so I like to use a bit of an analogy for this. It's that if you think about going out to play golf, you need a golf ball. You can't play golf without a golf ball. Well, it would be a very interesting game if you tried to do that, but you need a golf ball. But having the golf ball isn't enough for you to be able to play golf. You also need the golf clubs, you need the tee, you need the golf course. So it's kind of like that. It's that you can't have MS without having the EBV infection, but that alone isn't going to lead to MS.
Okay. Thank you for clarifying that, Brett. It's really interesting discovery, isn't it? So what does this mean for treatment options for people with MS? I'm thinking, will we all receive a vaccine against the virus, perhaps?
Yeah,
another vaccine, Brett.
Another vaccine, and interestingly, it is a little bit linked to the COVID vaccines that we have been receiving and talking about so much. So I guess there's a few points to think about here, but let's talk about the vaccine first. So yes, if we get to a point where we can really definitively say that this infection with this virus is necessary for MS to develop, then theoretically, and we still have to talk about this theoretically because no one's done any studies to test this yet, but if we had a vaccine that could prevent infection with this virus, then perhaps we could prevent MS from developing in the future. So it would be more of a preventative, protective vaccine. Now, interestingly, Moderna, who we've probably heard a lot about having created one of the mRNA COVID vaccines, have developed an mRNA vaccine for EBV that very recently they've just injected into the first healthy participant to check for safety. So it's at very early stages, but I guess one of the positive outcomes of the pandemic is that it's helped this vaccine technology really progress and accelerate. And so there is something in the lines for an EBV vaccine. Now, there's a lot of water to go under the bridge with that. This isn't the first attempt at an EBV vaccine. There have been ones that have been trialled before that have failed. But hopefully with this new technology, this may be more successful. Of course, even if the vaccine itself is successful, we still don't know whether that would actually be successful at preventing MS. But it's quite an exciting thing to think about, that potentially we can have a vaccine that can prevent infection with a virus, then that could potentially prevent MS from developing.
It's interesting, interesting developments. And I just want to clarify as well, when you mentioned there's a bit of a link with COVID, there's no link with COVID and MS. The link is with the mRNA vaccine development, isn't it?
Yeah, fantastic point, Nicola. Yeah, it's not that there's any link to COVID. It's just that the same technology that was used to create the COVID vaccine is being looked into to create a vaccine against EBV.
Yeah, great. This is the benefit of talking to a layperson, Brett, because I can ask the questions, hopefully, that some of our listeners might walk away with. So that's potentially really exciting news. What about the people who already have MS? Is there any research that might benefit them that's come from this?
Yeah, so the EBV story is interesting beyond this idea that it may be the trigger for causing MS or part of the cause of MS. There is some evidence to suggest that it may also be involved in the disease progression of multiple sclerosis. So one of the interesting things about an EBV infection that separates it from other viruses and other bacterial infections, for example, is that usually when we get infected with something like this, the infection happens, the immune system responds, we may get a little bit sick, but then that infection is cleared and the immune system, completely wipes it out from the body. EBV is a little bit different. EBV doesn't ever really get completely cleared from the body, and it essentially goes into this process of what we would call latency, but it's kind of like hibernation. So it just stays in the body. It's not causing any problems, really. It's not really replicating or doing anything like that. It stays there dormant.
It's a bit like if you get a cold sore, isn't it?
Exactly,
that herpes virus stays latent, doesn't it?
Yeah, and they're from the same family of viruses. So yeah, fantastic point. And so what's thought is that this EBV laying dormant can actually cause problems beyond that initial thing, that it may impact on disease progression in multiple sclerosis. And there are some ideas about that based on the fact that it tends to stay dormant in B cells, which we know are important in multiple sclerosis. And we know some of the current treatments for multiple sclerosis work on deleting those B cells. So this is ocrelizumab or Ocrevus and rituximab are both treatments that look to delete those B cells. So it's often been wondered whether part of the reasons why those therapies are effective is not only do they have some effect on the immune system, but also maybe it's helping to clear some of that latent EBV infection. We also know that EBV tends to hang around near parts of the central nervous system, and we obviously know that that's important in multiple sclerosis. So with this idea that perhaps this latent infection is important, there have been people who have been looking at seeing whether or not clearing that infection from the body completely can act as a therapeutic for multiple sclerosis. And one of the key drivers of this is actually based here in Australia, and it's Professor Michael Pender, who's based up in Queensland, and he's been for a long time interested in the role of EBV in multiple sclerosis. And so what he has done, and there's also now trials going on in the US, is they've looked at this method for clearing the virus where they take T cells out of an individual, and he started this with Michael Pender started this with a single individual here in Australia, where they took T cells out of this individual as a person living with secondary progressive multiple sclerosis. They took their T cells out, and T cells are cells that are part of the immune system that are really important for clearing virally infected cells. And so what they did was that they then cultured those T cells in the lab in the presence of EBV, with the whole point of this then really hyperactivated these T cells to be able to search and destroy any cells that were infected with EBV. They then put those T cells back into that individual and saw what happened. And the idea here was that it did clear the virus, and they did see some clinical benefits for that individual. They saw improvements in fatigue, improvements in mobility. Now, anyone who's followed MS Translate or has heard me talk about these things before knows that if we're talking about research, when we've only got a single person, we can't really draw any conclusions from that. But it was a really interesting finding and helped them then go on to do some further studies in this area. They've done another small study, which again showed some positive benefits using this approach for people living with MS. And now there are ongoing trials using a very similar approach. They've changed slightly how they're doing it now in terms of they're not using a person's own T cells. They're using healthy donor T cells to do this, to see whether or not this can be an effective therapy in people living with multiple sclerosis. There's a similar trial that's also being done by a group in the US at the moment. So these are still early stage clinical trials, but it's really interesting to think that, actually being able to target this virus may provide a new treatment approach for multiple sclerosis as well, especially considering it's a very specific approach and it's very targeted. So we would think that an approach like this potentially would come with less side effects than other medications. Now, it's a very early stage. We need to see what the results are like. But again, it's an interesting thing that we'll be following closely.
I can't help but feel a bit excited with that news, Brett. What are the potential timelines of all this research? Because it can take ages, can't it?
Yeah, it definitely can. And so, with these clinical trials, they're early phase 2 trials, and I think they're still potentially in the recruitment phase. Recruitment for trials has been particularly difficult over the last couple of years, obviously, with the COVID-19 pandemic. But so we'd still need to get through those trials, get the results of those, analyze that, and then proceed into phase 3 trials. So it's still a number of years away. But I guess what we've seen over the past couple of years as well is with appropriate resources, things can progress pretty quickly.
That's right. We've seen that things can turn around quickly, haven't we, with the right support?
Yeah, exactly. So, it's not something that's going to be available in 2022. But, over the next few years, we should certainly see some more development of it and hope to get phase 3 results. I would have thought, within the next 3 to 5 years might be a reasonable time frame from it. But it's always difficult to know, and it still needs to be positive, I guess, to progress through all of these things.
It's great to know that this latest information helps both, or potentially helps both people who might be at risk of getting MS and also those people who already have MS. So thanks, Brett. It's fascinating information. I love the fact that you're across it and you're able to explain it really well to our listeners. And it's a source for some hope, I think.
Yeah, definitely. I think it's a really interesting area that we've known. I think one of the key things about this is we've known about EBV for a long time, but what it shows is that if people keep doing the research and keep pursuing these things, new things can appear all the time, and they can potentially have really significant outcomes. So, I agree. I think it's a really interesting and really exciting area that we'll continue to follow.
Brilliant. Thank you so much, Brett. And just as we close, I just want to ask you, what topic do you want to do our next research update on?
I think we might talk about remyelination. That's always an area that is of keen interest to the MS community. So now moving away from, not necessarily stopping, but starting to repair damage that occurs. And I think that's another really exciting area. That's the next big step in terms of how do we manage multiple sclerosis. So why don't we talk about the latest research in that?
Let's do that, Brett, and listen out for that next research update episode. So thanks, Brett. And I'm obviously, like our listeners, really interested to hear what's happening in this space. I know you're watching it closely. Thanks again for today's podcast, and thanks to our listeners for listening. I know it's been really informative. I hope it's been really helpful to you as well. Cheers, Brett.
Thanks, Nicola.
And if you have any specific MS concerns or queries, if you want to speak to any of our team, to nurse advisors or social workers, if you'd like peer support, employment support, NDIS, etc., we're here to support you. We'd love to hear from you. Please call us on MS Connect 1800 042 138. Subscribe to our podcast so you can keep up to date with the research updates from Brett and from MSRA. And finally, a big thank you to Darcy and his team at Pro Podcast Productions for their generous support producing our podcast. Bye for now. Thanks again, Brett.